They will make me sit down and learn more about it because I have to present. So it's going to be fun.
Teaching is a great way to learn something.
I agree. So yeah, I'm excited.
Hey Sam, hey Al.
Even guys.
Tonight we just have project reviews and open discussion. I don't know if there's some show and tell. This week I've been working on static testing all of the kinetic release packages. So that's been interesting. There's a tool that they put together. If you have seen this one, the HA-ROS, it's for high assurance or static analysis of ROS, and it produces a nice visual display of each of the packages and the issues, coding standards. Shows how if it's a meta package, it shows how they come together. It lists all of your issues. So right now we're running this against basically all of the distro for Kinetic, and then we'll be putting the results up onto the ROS wiki. So a lot of programming that I haven't been doing in a while, so it's been a stretch.
Interesting.
Your mic is muted, Al. If
I was just a comment that it was 3 o'clock in the morning in Zimbabwe and Colin was on.
Yeah.
You look
How are you
bright
guys?
and vibrant, man. What the heck?
I finished blending.
nice. Sam, how's your project going this week?
So I worked on the URDF Zacro file that we have it under the lawn tractor. It's pretty interesting. So we're getting the URDF right. So there are like something within the launch file. There were like a couple of issues that actually launching, Let me share my screen. I'll just go through things a little bit so everyone can actually look at it. So let me know if you can see my screen.
Yep, we can see it.
Okay, so I actually just, just clone the package under the lawn tractor, and then I was looking into the file, which is this macro file, and I've worked on it a bit. Take a look at that. So for simple URDF, you don't need the XML namespace Zacro. But if you're using any of the Zacros, we're just going to go through a little bit of URDF too. You will need the to add the namespace Zacro so that you can actually use a Zacro. Now remember this lawn tractor that we wanted to actually design in a way that the URDF will show the kinematic diagram for it. So we have the lawn tractor, let's say, for example, right now it has a base link And then we have the base footprint link. And then we wanted to also put the laser link and sorry, the camera link and the GPS link. So there's no laser at this point. So all of these links basically that we wanted to actually put it into the kinematic frame, and then the REP 103 and REP 105 actually both protocols suggest that you can have at least the base link, and then you will have the base link frame, and then the ODOM frame, and then you will have the map frame and the world. You can define either or, because both are the actually the world fixed frame. So you take the ODOM or the map. And then if you have more than one robot, it's just basically you might have to introduce the Earth as a reference frame. And all of these things, that you can do it through the launch file. So coming back to the URDF file, as you can see over here, there are like URDF has like two important elements. One's the link, basically, which is quite obvious, and then the other one's the joint. So once you define that, how you wanted to actually design your, the links and your kinematic diagram, I think it's just one of the most basic and most important thing to think about it. So here, how you define a link, is, well, Matt and I had an interesting conversation on the Ackermann vehicle, and how, the center of, the rotation and the center of the body, and then how the Ackermann actually should take the instantaneous center of rotation, and then how we put the base link right there so that, we can mimic the Ackermann vehicle with the steering, so that's the whole purpose. And we wanted to put the base link, let's say, for example, for a simple car-like vehicle, just right at the rear axle center, so that we can actually mimic the whole, the car-like steering, So that's where we wanted to put the base link. The base footprint is basically the projection. Usually is the projection of the base link right onto the ground. That's mostly used if you are designing the biped or humanoid robot, that would actually just right at the ground, so that, if there are any obstacles, and if you're walking through that, if the robot's walking, it just be able to actually avoid some obstacles, so that's the main, the idea behind the base footprint. It's just nothing, basically, it's just the right down projection for the base link in most cases I have seen. And then you have the transformations that's defined, basically you can have your base footprint, and you can go from there. Your ODOM is just basically you wanted to start it in your base link reference frame just in the beginning, but remember, the ODOM is not the moving frame, it's the fixed frame. And then that is an important distinction right there, and people do get confused when we're just defining, and it is asking questions that why why we need like a map frame, or just why the ODOM is not the moving frame, and why we have to connect it to the base link and sort of things. But base link is just the one that's actually your the robot's pose, and it would just maybe the moving link. In most cases, but your ODOM is actually your fixed frame. You have to remember that. Now that actually comes after, once you model this, the whole model. So in this case, we talked about the base footprint, and then just don't. Over here, I got the chassis too, but then let's take a look at the GPS link, which is basically, again, a link that is mounted on your vehicle, right? And then you would know the geometrical dimension for your GPS mount, basically. And that is your GPS reference frame. Imagine that actually getting the X, Y, and Z coordinates, because it's GPS. And it gets that data into that GPS frame, basically. That's how we should understand that. The camera link is the same thing. So you have the cameras mounted right in front, or anywhere for that matter, and then it would actually get the data into that frame. So let's say we have all of these different frames, and then now, we have to connect these frames because those frames are kind of interconnected, and then they're like, the basic assumption is all of these links are the rigid body. So it means that there is no flex allowed anywhere. So it means that, it would actually, we can be able to apply many of the, the physics principles of the rigid bodies, and then that's very important. Defining of the link is, let's say, for example, if the name, first of all, and then this is really cool. The name's important. There's visual elements to it. So over here we have the visual element. There is a collision element, which is also important, and there is also an inertial element, which is very important when we can talk about that more when we get into the gazebo thing, which probably is just one of the next, the meeting stuff. So over here, let's say, for example, if I'm defining a base link and I'm saying visual, and then basically I can do the origin. So my origin is like, okay, where that link is basically, so it's like at my origin XYZ, which is basically 0, 0, 0 and RPY 0, 0. Now in this case, when I say 0, 0, 0, everything's in meter, and everything's in radian in terms of the, the degrees and the angles. So one thing that you have to make sure that if you're defining any of the dimensions over here, it's everything in the meter. So if you're actually, the most important part, that you need to remember this, just because sometimes your model is in either inches or mm, so you just have to convert that into the meter. The radians parts is really easy, actually. You have to define this in a radians, but then there's a quite convenient dollar construct, that would actually define the angles for you in radians. So for example, I have used one over here. So instead of, you can write any value of the radian, obviously, but the easiest one that I found is just use the dollar construct, so it means that, you can define the pi directly. You can actually also have the multiplications or divisions or or just any way you wanted to use this, you can actually use that. The similar way, like in this case, you got, let's say, for example, I wanted to have the base link have some kind of a shape. So I'm just using the geometry, the tag, and within that I'm saying that, okay, this should be the sphere, and then my radius should be 0.05. So it's just like, remember, this is again into the meters, So I just wanted to have that. Well, I have something of a representation, that should show my base link, and then over here I'm just using sphere, just very simple. And also I can have the the material name tag, and if I wanted to assign the color, okay, I can just simply do the RGB. Otherwise, it will just take the default color. And then this is my visual link. I can similarly add the more tags for the collision. And also I can do the inertial. So that part's done now, and then this is how you can define, all the links. The one most important part, and then just where the power is, where you can also, instead of defining, just this plain geometry, like very primitive objects, you can also do the mesh. So it means that you can have your CAD file, so be it it's in DAE, which is the Collada format, and also the STL, which is the stereo format. So you can have both. The preferred, the format is DAE, just because you can have really the color and the texture, that you can show, to the model. But you can use basically both, depending on your requirement. If it's just more customer facing, you might want to use some more pretty color and the texture so that it looks good. And then the most important, the most important tag, the part of the element is the scale. So in this case, many times your model may be in millimeters or inches. This would define, and you can scale it down or up. In most cases, people have used 0.001 just because they're like coming from millimeters. So it's like 1 divided by 1,000 that you can actually define over here. Also, you can adjust the origin, by adjusting the XYZ and the RPY parameters. So that's basically how you can actually also show like the visual of that link, and by using the AnyCAD data, whatever you have. And then you can have lots of data that's available freely on the some of the open source sites. And then there are like, you can also use the FreeCAD, and you can also use the Blender. The most of the time, what you're probably doing is just the translation of the CAD model, or if you're scaling it, or if you don't like the origin, you're just setting up the origin and then translate or convert the one format to the other. I usually use the neutral formats. For me, DAE is just a kind of a new format. FreeCAD has just the crappy support, for the DAE file. So I started using a Blender just for my, the formatting and, the initial translation and rotation things, so that Blender has the wonderful support for the DAE, but you have to use the new version to open up that model if you have DAE. Over here again, this is just the link, this definition. Now let's go to, we will take a look at the Zacro later on, but this is how you can define the Zacro. We can go through a tutorial in Zacro in detail, probably in one of the next meetings. But then over here, it's just the most important thing, that how you define the joints. Now, once you have all the links, that you have to define the joints so that it knows that how it has to work. Now, joint has its own XML tag, and then you have to just go through the elements, which is pretty easy. Where you have the, this is my base footprint joint, so how it is defined is like you got joint, and then you got a name as, whatever the name you want to do, and the type is very important. There are different type of joints, so be it, you have the revolute, you have the fixed joint, you have a planar joint, or you have the continuous joint, and sort of different types. You can actually refer to the document, and it will have all the types. Now, the fixed is like you are locked in. There's no movement from that one link to the other. And remember, the joint is very important, because joint is your TF frame actually, because that's defined, that the reference right at that joint. So now I have to define the parent link. What's my parent link and what's my child link? Now you may remember our URDF is just quite rigid in this sense. You have only one parent. You can have a multiple child, but you cannot have multiple parents to the joint. It will not work. So it means that it has a structured, the hierarchy. And then once you understand that, I think the modeling is just probably it's more easier. So your child link over here, base footprint, let's say base link over here, it's my parent link, that's how I define it. And then my origin, so where at what distance from my parent link to this footprint link, it's actually located. And then that's what I'm defining it over here. That it is like in X direction 0 meters, in Y directions 0 meters, in Z directions basically negative 0.25 meter. And is there any rotation? So my X rotation 0, my Y rotation 0, my Z rotation 0, for example. That's how it's defined. Now I go and define the chassis joint and then say, okay, what's my parent over here? And it's a base. And then I'm also defining the chassis, with the parent base and where it is situated, basically. So this is my origin data where exactly the frame joint is, and this is like 0 meters X, 0 meters Y, and then 0.25 meters in Z. So the REP 103 defines the coordinate reference frame, and we use the right-hand rule. So it means that mostly you have to remember for your vehicle, your X is forward, your Y is left, and your Z is up. And then that's why all the reference coordinate frame that you need to actually be looking at and defining that way. So the GPS point where the GPS located, my joint names and the types, again, the fixed, my parent link, you have defined the parent link for the GPS joint and what's the child link, and then again, the distances. And so be it, like the camera joint. And this is over here, I have used the negative pi divided by 2 to define my rotation in radians, so you can do that. And just probably pretty easy, that's how it works. Okay, so the whole thing's over here, and then we can launch this, the whole frame, the URDF, by using the launch file. Launch file is basically important. Let me. I'm not sure if Matt, we have time.
Did you want to show what the URDF looks like?
Yes, so that we can. I can show you quickly actually. So here is the launch, the simple launch file, which is very, very basic launch file. Let's say for example. And this is how.
You have a lot of
This
background.
is how,
noise.
if you wanted to launch the RDF Zacro file, this is the most basic, the launch file that you wanted to use. So you're declaring the arguments for the model, and then you set default, then where your package is, and then where your URDF is. That's exactly you wanted to define in terms of the argument in the model. Then you have the another argument, which is basically GUI, and then say true, and then you have the arguments for the RViz config. You can point that to your, the folder wherever you have your RViz configuration files located. Now, over here, what you're doing is loading the model file to the parameter server, so that it's just available. And these parameters like used by the joint state publisher and the robot state publisher. So over here, you say the robot description, and then you say the command, and then basically you're loading this to the parameter server, so that it can be used with the joint state publisher and the robot state publisher. Both the packages uses that basically, and then it would and there's a RViz spinning of the RViz with the launch file, so you can basically launch the the RViz with all the configurations in place. And then once we launch this, let's say for example right now this has the lone tractor _1. So if I launch this file, let me see. I'm not sure if you can actually, let me see if I can stop this and try and share my another let me see if this works. Okay, so I'm sharing, let me zoom out, and I'll just clear. And then my ROS launch, if I launch this, and then my OSR, the package would be, I'll just quickly check. OS. And then it'll be OSR RViz. So once I launch that, do you guys see the RViz or no?
I think RViz will show up in a new window.
Okay, I have to share that actually screen again, so it will be showing up over here. So now with that model, if I am, let's say for example, using my base footprint over here. So this is what exactly we went through. It's a very simple kinematic diagram of the model that we have just gone through. So over here, as you can see, I have actually my fixed frames, like over here, I put the base footprint just to show. And then now you can see that my base link over here, just refers to the base footprint. This is the another URDF. It's a similar concept. And my GPS frame actually links to the base link. And then my camera frame, I put it into the exactly the optical frame. You can have this in any way. For camera, what the optical frame is actually your Z is in front of you. So for your camera, basically your camera frame has your Z is basically your depth, in front of you. Basically, it's not X. So I have rotated that frame, and then it would say your Y would be your actually the further down, and then your X would be your right. So that's how the camera frame would look like. You can have any, but then this is the preferred, the frame. The GPS frame, would be the same way. Just your red is X, your green is Y, and your blue is Z. So that's how you remember your RGB. Your R is your X, your G is your Y, and your Z is your blue. And then this is how it actually. This is my X-axis. So if I have to put my robot, it would be facing this way. If so be any other car-like element, for it. Now let me. I can actually go and shut down, and then I can launch the launch tractor. That's how it would look. And then I can show that quickly. And so be simulation.
So this is how you tell Ross where all of your sensors are and how big your vehicle is and what the dimensions are for everything.
Right now, okay, hang on. Let me see if we can first of all see my screen. Okay, so this is your project, Matt, what you were working on. And this is how it's launching right now. So as you can see now, we have actually placed the whole CAD data. This is the AE file, basically the whole rendering of it. And you have your TF frames, and then you can see that how the tree is being built. And in this case, you got the map frame already defined. You got the auto, you got a UTM frame, which is basically is not connected because there's no data from the GPS at this point. And so this is how the whole tree of the URDF looks like. So it's like you got the base footprint, you go to the base link, you have the chassis over here and the GPS and camera. We wanted to get rid of the chassis, which is the same thing as the base link, and then we'll just put the graphics to the base link. So for over here, as you can see, this is cool where you can, actually I can reduce this to 0.25. And it basically should, let me see. Oh, sorry. Because it's over here, it links to the chassis, yeah. So I can actually reduce the transparency of it. So you'll be able to see like how all the, the links are connected in the vehicle. So you got I know that we got the base link and the base footprint. That's what I am actually trying to get at, because in this case, I have some offset with it, but then it's not actually being rendered because the launch files has some settings probably that's actually causing this difference. But this is how, it would look, in your vehicle based on if you have the mount parameters and you can define the GPS and camera mount. So we're still just work in progress. Obviously, we'll just keep working on it. This is what I have to share. As promised, we'll just go to the URDF. We'll go to the Zacro maybe next week, and then Gazebo. So people can connect to it. I'm not sure if people already know. I'm sure that this is basics, but I think I just wanted to go through it. So that actually is good for me too. That if I like you guys said, right? Teaching is just the best thing, So you learn more by teaching. So that's what I'm doing too.
It's great, Sam. That's a big help. Learning how to position all of the sensors and get everything lined out. That's a big part.
All right.
How's the volume? Am I getting feedback now?
No, you're good.
Okay, thanks. Thanks, Sam. Al, are you up to do the show and tell?
Well, I'll do a little bit. First, I just want to say, Sam, I'm glad this is recorded so I can go back and say, hey, Sam, I'm just helping you learn by you teaching me.
That is so true. I mean, I'm not denying that.
Let me see. Where's the share button? There we go. So I've been operating in the physical world and focused on steering. Let me get the right image up. So Matt and I are using this electric power steering motor that comes out of, I think it's a Saturn Vue and a bunch of other products. And when you order one, this is about what you're going to get when you order it. So this shaft, you can see that, right, Matt? Just nod, yeah. So this is the shaft that actually connects to a steering wheel in production, and on the back side of this is the output shaft of the motor. This is the worm gear that's driving this, and this is the bespoke or proprietary motor controller that they have. I was, Matt has his installation, and I was just trying to move us along a bit, and so I was trying to make this, basically one powerful servo in a compact unit, and put the electronics for controlling this on board to this device, so it becomes basically a plug-in device, a plug-in servo. To do that, I taught myself Fusion 360 and did some modeling and 3D printed this bracket to hold the Citron motor controller, which is a 30 amp motor controller, and then another little part to hold the Teensy. So the notion would be, you've got control commands coming in via USB into the Teensy, and it's directing the motor controller to do what it's supposed to do, and the wires, you can just barely see the motor is over here, and the wires then carry the electrons over to power the motor. You probably can't see it very well. Let me zoom in a little bit. There's a U-joint that's a purchased part, that would then fit onto the shaft of the actual steering control rod. So again, trying to make it all one unit. I was trying to go the next step. Matt, in his version, had the angle sensor as a gear on another gear on the unit, and I was trying to get into this shaft, this shaft turns at the same rate and speed as the output shaft. So I was trying to figure out how to get this thing off and then mount a potentiometer basically here, so that then you've got angle sensing, motor controller, compute power all in one unit. So that's still TBD. So the picture of my my broken or bent punch is an unsuccessful attempt at. There are pins that go laterally in here, and so I was trying to drive that pin out so I could elegantly remove that shaft, as opposed to hacking it off, which is what I've done so far. So you
Did you just cut that with like a hacksaw to get that off?
yeah, that was the, what do you like to call it in Seattle? The
Get her done.
what did you call it? Oh, I forgot. I wasn't accustomed to it being called that in Washington. The redneck approach. Yeah, that's it. Yeah, so anybody got any advice on how to drive a pin out? I was just going to then next move it to a drill press and try to drill it out. So that was my next option. But anyway, so Colin, when you're ready to buy your motor, I've got a motor mount for you that you can at least a little bit more in an organized fashion, mount your motor controller and Teensy.
I'll remember that. I'm taking notes. Thank you very much, Al.
And so that's the wee bit of progress made in the last week or so.
Nice. It looks clean. So you'll run a USB cable from wherever you mount your main computer out to that motor?
That was, again, you know, I'm open to changing, but that was my that was my thought.
Yeah. You do have the option of going serial, but the USB is pretty clean and it works. Water and debris.
Yeah, and I mean, no doubt we've got to design a cover for that thing. I was just trying to get it together to figure out the sizing and to, you know, like I said, I think before on one of the calls, I program about as well. I 3D design about as slow as I program, right? So this is an iterative design.
Oh, I can help if you have if you have just like a 3D design. I can help you actually put that into the FreeCAD, and I'll get the STL files for you.
Yeah, thanks for that. I mean, literally, my issue is just to try to figure out, where do I want this stuff? Do I want it mounted in this orientation? Do I want it coming out this way? You know, how to plan for a cover for it. I mean, it's all that basic stuff. So I'm you know, I'm an IT geek. I'm not a graphics visual how to lay things out kind of guy. Anyway, it's a lot of fun making progress, albeit slowly.
Is your mount is subject to vibration at this point? Where you mounting this?
Well, it certainly would be. I mean, certainly. So you're going to get vibration from, you know, relatively slow motion of the motor, but you're going to get vibration from the overall unit. So there's, I mean, this is not production ready and, you know, certified for 100,000 hours. I mean, it's just trying to get things laid out. And
But it doesn't have no sensor on it, right? It's just the controller.
this is meant to be basically a big servo. When I'm in the, so the other sensors are going to be in different places of the unit. I'm just trying to make the motor, you know, effectively a servo.
Right. Yeah. Yeah. I don't. And it's just like it's a slow speed, right? The pretty low RPM.
Yes.
Okay. Yeah.
That's a good idea of attaching the encoder to the other side.
Again, just to try to make it one compact, relatively compact unit, all there. So.
That's cool.
Yeah, I mean, I like it.
It's neat. And then the other consideration is the amount of space to the orientation that gets mounted onto the tractor, and then the space around all that stuff.
Well, I mean, number one, do you have any concerns about trying to put it all together and put the motor controller and the compute power and the angle sensor all in one unit?
No, it's the, well, no. I mean, that's a neat way of putting the microcontroller on the individual device. Some people that's what the HROS people do, and that's neat. That's a good way to connect things up. It was just the space. I went to a junkyard this weekend, and I pulled out the shaft. The electric power steering motor connects to a, I don't know what you want to call it, but a shaft, and it has that U-joint on there, although it's welded to the shaft, but the other end fits. And, it's about this long. And I was looking at the space on the lawn tractor, trying to figure out how much room and then how to mount it in there if you want to keep it inside of that box. The gas tank mounts on top of the box.
Right.
So, but that looks nice. I like the way you did it, and cutting off that shaft is great. No reason to have it, I don't think, unless you want to manually somehow put.
Anybody have any secrets to driving out a very tight pin in a steel shaft like that? Anyone? Ferris?
It's just a spline shaft, that you were looking at, right?
No, the pin I'm talking about, I don't actually have a picture of it. It is laterally driven in the shaft this way.
Okay.
And it's about a 1/4 inch in diameter, and it is more powerful than my brand new punch.
What were you hitting that with? A sledgehammer? How did you bend that?
It wasn't a big sledgehammer. It was just a hammer, and it didn't budge at all.
Is it directional? Is there like a shoulder on the pin?
No.
No.
So I'm going to drill it out. That's when I get time. I'm just going to try to drill it out. See how that goes.
And then what will that do? Will that get you a smaller shaft from where you cut it?
It won't be necessarily smaller in diameter, but what I'm hoping is, you see this shroud around the shaft here?
Mm-hmm.
Make that bigger. There's actually a fair amount of space here and then here horizontally. I'm literally hoping I can fit the encoder or the potentiometer, if not completely, mostly inside of this, and then 3D print something that will connect the potentiometer to the remaining part of that shaft. That's the hope. So that's where we're at.
It's great, Al. Progress.
Inch by inch, man, or millimeter by millimeter.
Different scale.
And I looked at Blender, Sam. Oh my gosh, did that look complex? So
It does. But I think I can briefly touch on both the FreeCAD and the Blender, and then I think how we wanted to use it. I think we can touch base, like sort of very needed functionality, and that's it. We don't have to go deeper anywhere, because I think DAE it's one of the preferred format, and Blender has a wonderful support. I mean, hate to say that the Blender itself is looks complex to me too. But I use FreeCAD, and I didn't want to go into the Blender, but then I think for the DAE format I had to. So we can do short tutorial. It's very, very easy, and what we really need the Blender for, that we can do. I think should be fairly easy after that.
It's neat. Colin, how are your classes going?
Come again, Matt.
Oh, I was wondering how your classes are going. Your school?
Not as smooth as I expected. The assignments are too close. but I've decided to scale down the number of modules that I take in order to allow myself time to work on my loan project. It's easier to go back and to look for things than whilst working on something. It's just like coding. Unless you do the coding, you're not going to know more coding by reading more books. So I think the more I start, I'm actually going through paperwork just to see what I need for the lawnmower, what are the things that are required. Even when these guys are explaining things, I can't claim that I am on top of things. I was wondering which software or which language was used to write SIMS model. Whilst I could understand that when it comes to talking about parent and children, but it doesn't look like C++. It does not look like Python either. So I'm still way back. What was that, Sam? The what do you show? You've just shown us. Was that?
It's the URDF. So I should have actually clarified that first. What it's called is the Unified or Universal Robot Description Format. It's really simple XML format schema, that it was written in. It's a really simple XML file, and ROS, basically has the modules that can read URDF files, and it converts into, basically converts into visual format by the RVs, and it can be used into the many other modules. So if you're designing the format, you can use it into the state publishing. You can use it as a, the transformation, which is the TF module, and basically many other uses, and then very simple language. It's predefined. So it means that, you have all the XML elements defined, how you write the URDF. And once you build the whole tree, it will be very easy to see it with the RVs. And that's where I saw the launch file. That's the minimum configuration in order to actually visualize those links. So there is no programming there. I mean, it's just simple XML format following.
Yeah, I could tell there was quite a lot of cut and paste as well and modify. The format is more or less the same, repeating and changing the variable names.
You mean to say in my XML, the format file?
Yeah, in the format file. I'm saying you didn't have to write everything that we've seen. You could cut and paste and modify the variables.
Oh yeah, you can write your own snippets, which will be very useful to you. So when you actually write the URDF, you can basically just call that kind of a macro, that you don't have to type, all the details every time, basically. But yeah, I mean, I can. That's like kind of on the list too. If I'll share the snippets actually, and I was thinking that I should share it into the notebook, or I can share directly onto the our Slack channel page. Either way, I mean, if I can't find to write the document, then I'll just directly share it onto this Slack channel, so that you can use it. And you can create that file once you have the URDF file, and next time we'll go to the Zacro, which is like a little bit, it enhances the functionality of the URDF. It is also the part of the XML format file, so that you would understand that how you model, the kinematics, like for the robot. So I think it's easy. There's no programming needed there. just following the formats.
Thank you. Thank you for your discussion as well. I'm encouraged. Now I can see why you were insisting that we should follow procedure.
We're trying to make it easy for you, Colin.
Yeah.
We keep you in our mind to say, okay, how are we going to do this so Colin can have it a little bit easier than us?
Al's the
Yeah,
point of
yeah,
the spear.
no, thank you.
That is true. We can build on top of this, and we can take it all the way to we can put it into the localization and the state publishers and stuff. I mean, if we can go up to that point, you know, it'll be more easier for everyone at least to connect, and then start writing, because I think those are the basic fundamental blocks. You have to understand all the different reference frames, and then my try is to teach myself as well as everyone else, so that, you know, you just not confused about the frames anymore. And so be it, if you wanted to use any sensor, if you wanted to use the GPS or laser, you know, if you wanted to use the cameras, if you wanted to use, you know, the ultrasonics, you know, or so be it anything else, you would understand the concept that what's the data that's coming from which reference frame, and where I need that the most in order to localize, or in order to publish the states, you know, or in order to actually feed it to somewhere where I can make use of it. So I think that's part is linking up those things are very important, and visualizing it. I'm learning it, so whatever I learn, I can share.
That's cool. Quick survey. Does anybody have Docker installed locally on their machine? Okay. That's funny.
On the other note, I wanted to point out that Amazon on AWS just released the Robo Maker, and it was like out of the blue moon. I was so much surprised. That tool has ROS inbuilt, along with all the deep learning and the machine learning tools that you'll be able to deploy in AWS with like fewer commands and stuff, you know, and it'll be for the scale, you know. I encourage everyone to check it out, AWS RoboMaker, and like I said, it caught me with surprise, because I had no like prior view of Amazon's coming up with something like this. It was nothing in the news. It was just out of the blue moon last week, you know. It was just the whole tool was released, and I was like, wow. I know that the Google is trying to release that next year, and I know that Microsoft's also working on it, and everything has the ROS, and it seems like ROS is picking up as a mainstream, and I think there's a lot of tools out there, like a lot more operating system that now it's getting the support from, and I think the Open Robotics is working on with so many companies, you know, in collaboration to actually launch these new tools. And check it out, the Amazon AWS Robo Maker.
I'm Googling it, but I'm not finding, I bet, what you want us to look at.
I'll ping.
I saw what you're talking about. They've also split it. It's a course split into 3. You've got to take the first portion. After the first portion, you go to what they call the intermediate before you go to the final one. But I wasn't sure whether it was good or it would help us in what we are doing, because I didn't want to dive into too many things and then you end up doing none of it. But I'm encouraged by what you are saying. You seem to say it's a good thing.
I just posted a link for the AWS.
Found it, thank you. So is this like a wrapper around ROS to make ROS easier?
It's like, that's what they call the cloud robotics. So it's everything in the cloud. And before that, they had their own tools, but now everyone's like, putting the ROS under the hood. And then all the other, the tools that's available for you. So if you want to deploy something at the bigger scale, like for example, some industries just wanted to roll out certain things, with the ROS, they're like everything's on AWS now, so they can actually be pulling data from, the cloud, and then everyone's working on the cloud. So it's everything like within the cloud, my understanding right now. But I think it's very promising. I mean, I looked at it, and it has PDF, 200 pages PDF, which explains most of the things. All we have to learn is the AWS, like a tools, syntaxes and stuff, in order to just see that how it works, basically in AWS. Everything else is similar. Now, Amazon has also opened up their SageMaker, which is their machine learning tool, and then all the trainings and all the videos. I guess it's a training. I haven't seen the videos, anyways. And then everything else, so that if people are interested, they can also take a look at those tools. But it is definitely exciting.
It'll help get more people involved with ROS, which is always a good thing. Make it easier to get up and running.
Absolutely.
At the top of the hour, is any other comments or?
Not from me. Thank you very much.
Thank you, Sam, for presentation. Thank you, Al. It's good seeing you, Colin. Lawrence, thanks for being here, learning more about robots.
Hey, guys.
Hey, guys. Thanks, everyone.
Okay, thank you very much.